Welcome to Securing Rancher Containers with Open Source. My name is Ryan. Happy to have you with us today. Just a quick check for the audience, no prerequisites. Uh, Hopefully you're somebody working with containers or Kubernetes. Awesome, you're in the right spot. Maybe you're considering using containers or Kubernetes. Very awesome, you're also in the right spot. Perhaps you're both of those, or somebody that's interested in open source security tools to help better secure cloud native workloads. If so, you're in the right spot as well. Today, we're going to cover cybersecurity framework and application container security. Those come to us by way of our friends over at NIST. We're also going to talk about components of securing cloud native workloads, Kubernetes, and securing tools with RKE2, and then also dive just ever so shallowly into a very deep pool on tools to secure cloud native workloads to include posture and vulnerability management, networking, threat detection, and then finally, a call to action. As I mentioned, my name's Ryan. I'm a solutions architect here at SysDig, where I support the US federal government and federal systems integrators. Before that, I had a focus on security. Am I a developer? Not really a good one. Do I understand that? Yeah, just enough to get myself in trouble. But that's okay. A lot of times, the folks that we see in my position and probably similar in your job as well is, folks that are maybe a developer or a cloud ops team member or a security person or a compliance person, or the list goes on and on. It's 2021. IT is a team sport these days. At the end of the day, SysDig has built a business around open source. I like that we have things that we've brought and shared to the community, things that we are using from the community to help provide a unified platform to help keep customers safe and running cloud native workloads confidently and securely. A couple of things that we're really proud about is we're creators of SysDig and SysDig Inspect, as well as Falco, which is a CNCF project. Maybe you're familiar with those, maybe you're not. Before diving in, I did just want to mention the cybersecurity framework. NIST has one because, of course, they do. If you ask my wife about cybersecurity, she'd say, honey, I want to be, what do you think of cybersecurity? And she'd say, well, I want to be safe, which is fair. She's in HR, and that's a reasonable thing to want to be. But, if you are somebody that needs to go a bit further and provide objectionable, actionable tasks to anchor to so you can achieve, I like this a whole lot because it says, hey, we need to identify what we have. We need to make sure that we understand what is important to us. We need to protect that. And then we need to have, the capabilities and the instrumentation intact to detect and respond, and then ultimately recover if something happened where it wasn't ideal or optimal. So it defines the entire breadth of cybersecurity, and it also brings together both prevention and reaction. So you can map those to actions or areas to watch out for and protect. And then similarly, NIST also has a special publication for application containers. It's called NIST SP 800-190 because, of course, they do. They have something for everything. I sort of recently learned when I was just sort of joking and asked about a thing, and they're like, "Yeah, it's actually." And one of my really propeller head friends was able to list off the SP for that. But at the end of the day, application container security guides for us interested in containers goes over the overview of containers, their technical capabilities, the architectures and uses, explains the major risks for the core components of application container technologies. It recommends countermeasures for those identified risks and defines threat scenarios or examples of threat scenarios for containers. And then I think the key thing to sort of focus in, if you're not familiar with this, is it provides actionable information for planning, implementing, operating, and maintaining container technologies. And then very traditional, the government, they'll kill you with all the appendices. There's 5 appendices in this. I learned while researching this. So NIST 800-190, Ryan, you work in Fed. I've heard of NIST. I may be familiar with federal information processing things. That's certainly FIPS, which is a thing. We'll talk to that in a minute. But what about NIST 853, you might ask? Very good question. NIST 853 is something that I get asked about a lot, and it's a list of technical and non-technical controls that support the development of secure and resilient federal information systems. When I get asked about 853, I will talk to people. We have mappings in our product that map to and show you compliance or benchmarks to NIST 853. But when I get asked about 53, I like to say that 800, 190 is sort of like a Lego brick that sits on top or connects and extends 853 and brings awareness for container specific risks. Maybe that's something that you get asked about or care about. Maybe it's not. I see that all the time. And I know that NIST guidance is not only followed in the government, so maybe that's something that impacts you. But maybe your industry is similar, and that's something that's on your radar. Maybe it's different, or maybe you have additional requirements. Cool. I fully expect that. It's a lot of different things for a lot of different folks, and the risk profiles are certainly very different. Government, big target on their back. They want to make sure they're as secure as they can be so they don't inherit or take on unnecessary risk. Some places may be a little bit more wild west. Some places that you would expect to be very regulated and have an idea about this sometimes seems like they're the wild west, but I'm not going to get anybody into trouble today. If you don't know if you have compliance needs or requirements, ask somebody in your job is tasked with that most likely. Compliance is big. Things that would keep our compliance officer up, I'm probably super ignorant around and I wouldn't really care, but that's not an excuse. That's not a good enough way to sort of work because with a lot of these things, there are ways to check technical controls and spit out a report. And some of those things we'll talk about in just a second. It's 2021. You should want to be safe. That's a reasonable thing to do. But if you're one of those persons that says, oh, security is not my problem, I'd argue it's 2021 and we're all responsible for doing things securely to the best of our abilities. Really quickly, benefits of containers. This is probably very elementary, but they're immutable, purpose-built, and self-contained. They've got limited access by isolation and resource limits. Your developers probably love them. I can understand why. And there's probably a bunch more reasons why. But when you bring Kubernetes into your enterprise, you may have something like this, and your developer's like, man, we've got agility, we've got velocity, we've got this ability to do different deployments quickly. That's test science experiment, I would maybe say. When it comes to actually bringing those into production, maybe Kubernetes looks more like what you see on your screen because you've got all these different capabilities tied into protect, detect, secure, respond, all the things that cybersecurity framework talks about. And that's not uncommon. Turns out, things grow when they become popular. And when things get popular, we need to secure them properly. So we've talked about frameworks and we've talked about guidance. You may be saying, okay, great, get to the point. Well, here we go. I mentioned earlier that IT is a team sport, especially DevOps. And here's some of the areas that you should have strategies in place to help give your org guardrails for safety when using Kubernetes. Maybe you're running in a cloud service provider. So cloud security posture management or CSPM is something that you should be aware of and tracking. Maybe you're hybrid cloud or multi-cloud. With a good CSPM capability, you can track, detect, and do things regardless of the cloud service provider and have that guardrails for good hygiene and keeping everyone safe. We'll talk about that in a second. Similarly, maybe you have to meet some compliance frameworks to keep you from being, probably fined is a good way, or shamed to be not in trouble. Similarly, you may have benchmarks requirements. Again, these are things that are achievable. There's open source capabilities to check these, technical controls and then spit out a report. I like that a whole lot. Image scanning is something when I came to SysDig and I was becoming more familiar with containers, it sort of was like the de facto, the table stakes thing to do. Certainly, this is part of NIST 800-190, just like, everyone nowadays probably has antivirus on their laptop or endpoint. But don't stop at image scanning. There's a bunch of different places where you can insert image scanning through the CI/CD pipeline on your platform, maybe as part of jobs. Just a bunch of different ways to do that. And also you can use image scanning to go hunting for CVEs and vulnerabilities, which is really great. So keep that up, but don't stop there. And then runtime security and forensics is something that I like, and you're probably running this in traditional workloads. Maybe you have an intrusion detection system. Maybe you have host platform auditing capabilities. Maybe your cert or your SOC, if they get a notification that something's gone bump into the night, or somebody notifies them that Houston, we have a problem, they can go provide a forensics capability. If the same thing happens in containers, it's really nice to give your cert or your SOC a fighting chance so they can be successful with their investigation. Those capabilities are something that exists, and with the right instrumentation, you can enable them to have metadata around an event to include, remember back in the day, a network forensics capture, like a PCAP, was something that existed. Well, with some of the technology that we're going to talk about today, system call captures are available too, to help them understand the who, what, when, where, why, how on a container. And keep in mind, from our container report that we've done most recently, SISTIC, and this is for our commercial customers, not my federal customers, on average, 49% of our customers had containers that lived less than 5 minutes. Some containers lived as long as 5 seconds. But I mean, they also had or noticed some containers that lived as long as 2 weeks. So if you got a container running for 2 weeks, that's almost a virtual machine. But for the containers that live very, very shortly and are spun up, hands off by your orchestrator, if you get asked by your cert or your SOC, hey, we've had a problem, ooh, not a good place to be. But maybe that's part of your container growth and journey, and getting to a place where you'll get to that eventually, because you got a bazillion other jobs to get done. And sort of to that, why is securing Kubernetes hard? Well, it's because there are a lot of layers, and it's all the things I just talked about. Cloud service, cloud security posture management, compliance frameworks, benchmarking, image scanning, runtime security, and forensics. If you have point tools for all those, good. You're probably ahead of the curve. Maybe you have more. Maybe you're saying, well, Ryan, we're more of a check the box compliance type of group, and I understand that, and I get that as well. Some will sit there and be that. Some will go above and beyond, and that's okay too. Just depends on the cycles available and what's important to the agency or org. But it is hard because it takes in a lot of things. But sort of like math, which is maybe hard for some people, it is achievable. It is something that can be addressed. And I think when you find something that works right for you and your organization, that's when you can sit there and say, hey, yeah, we do have confidence in running Kubernetes at scale in our production environments. And we're ready to take this on and get the benefits without the worry of cloud native workloads. So we've talked about the different layers that you should consider using to keep yourself safe. Let's dig in and start with the heart of it all, Kubernetes. So just as that, there are a bunch of layers. Maybe you're using some, maybe you're not using some. You can deploy Kubernetes in a bunch of different ways. Similarly, each way gives you different abilities out of the box. Some are more complex. Maybe that's by design or your preference. Some are more vanilla. And again, maybe that's your design preference or by design. That's wonderful. That gives you options. Life's great when you got options. I like a bunch of different flavors of ice cream, but that's terrible because it gives you options, because sometimes you have to make a choice, and that's hard to do for some people. So let's focus on one area in particular. How do you make Kubernetes secure? What offerings help with that aspect of things out of the box? For me in Fed, I will say FIPS 140-2 is super important. That's for the communication and the accepted encryption schemes to allow that. So maybe you're similarly bound or you need to meet that. There are ways to enable that. That's generally not done out of the box, but it's easy to do. Similarly, all the distros that you see on your screen are capable of being hardened with the FIPS mode. RBAC control, man, if somebody could figure out RBAC control, this is something that we were talking about in school a bunch of years ago. They'd have a bunch of money on their hands because it's still something that troubles some people today, and it's been going on for a long time. So there are ways to achieve that. Maybe it's native Kubernetes, maybe it's using an RBAC manager like the one that you see on your screen, or maybe it's a commercial offering from Rancher or others that can help you do that too. Similarly, you've got this idea of hardening your nodes. So making sure that, if you're new to containers or running Kubernetes, you're nudged in the right direction so you can be successful as you run that. And if you're not, you can get a report and say, hey, we need to work some time period over some time period to achieve this. And that'll help you sort of get nudged in the right direction. And then hardened images is really great to reduce the attack surface, reduce the vector that you can be attacked on by just using the base minimal amount of what you've got in those container OS images. Here's a Kubernetes easy button. We work with Rancher, and because, like I said, I am Gov, they appreciate that our KE2 is something that's fully conformant Kubernetes distro. It focuses on security and compliance, and it's something that the government has accepted. It provides defaults and configuration options to allow clusters to pass CIS benchmarks. And they're done sort of automatically where you don't have to have a ton of work from your operator or O&M staff to do that. It enables FIPS 140-2. And then as part of the build from Rancher, they scan the components for CVEs using Trivy, which is an open source scanning tool for their build pipeline. Once you've got your foundation, you can build out your Kubernetes cluster to meet your needs and risk profile. So here's something sort of reading from left to right, starting to think about how customers are maybe thinking about securing their cloud today. And first is, identify. Understand what assets are running across all of your cloud accounts. Next, you want to identify if there are any misconfigurations tied to them. For example, maybe you've got an S3 bucket exposed, or things that, on the surface might be trivial, but with those things, you might have lateral movement where somebody could come in, worm their way through, and expose your organization or agency to breaches and or other compliance violations. Another thing, as you run your apps in the cloud, scanning for vulnerabilities in them before they're deployed in production is super helpful. Maybe you've heard the term shift left. So scanning early is a really, really super great thing to do. I encourage you to do that, but don't stop just once the container image has made it to your running platform. Continue to scan that because vulnerabilities are made known regularly, and things that were maybe not a super high vulnerability may be becoming one as more information and people get their hands around that and start poking at it. What's nice about this with containers, you can, fix those sort of easier than you could legacy monolith applications or architectures. So I like that a whole lot. But again, if you've got a small staff, you have to prioritize things. Just, image scan, image scan. And then, in addition to that, if you want to go further, certainly take a chance to become more informed on runtime security too. So this is a capability to help you understand suspicious activity in your cloud, and that's done by a number of ways. Maybe through connection with your cloud service provider and checking their logs. Maybe that's workload protection and noticing what's going on in your containers and seeing anomalies or outliers. Another thing too is, innocent idiot doing something silly, or maybe malicious insider, or maybe it's some bad actor from, some other place. Just want to make sure that you've got this idea or ability to detect suspicious activity. So when it is detected, you can respond in minutes versus days or months or longer than that, and be on the front page of CNN.com for the wrong reasons. So let's take a look at some of these capabilities a little closer, and we'll start that off with the Cloud Security Posture Management and Cloud Custodian. Cloud Security Posture Management is something that has been around for a bit. What I like about Cloud Custodian, it is open source. It's aware of the different cloud service providers. It can help you identify the different assets that you've got across multiple regions and across those different cloud service providers. Some examples of Cloud Custodian rules are detecting logins from unapproved IP addresses. As mentioned before, not locked down or exposed S3 buckets. Something that's new to me and I think would be a way to get in if you've got like some account that's got access to this and cause a lot of harm might be the ability to attach the virtual console cables to EC2 instances. You can write a rule to be on the lookout for that. And if that does, maybe wait that to have some high severity so you can go get a set of eyeballs on that to check out what's going on. Similarly, as part of O&M, I like that it can help you be on the lookout for SSL certificates that are about to expire. If that's something that you have to do, maybe your cloud service provider is taking care of that. There's a bunch of different ways that you can choose to go about that. Similarly, when you have your assets in somebody else's data center or the cloud, tagging them properly is important. So with Cloud Custodian, you can also enforce good hygiene to make sure that people are tagging things properly and provide guardrails for acceptable usage. And if they don't meet that, people get notified right away. And you don't have to have some person with a clipboard running around the office or getting on a plane to go yell at people in other offices. Today, we'd probably do that by Zoom to let them know that they've not done things right. I also like that you can do integration with notification services. So if a policy is violated, you can let this Yelp for help and tell you about that. Similarly, it is also possible for you to configure remediation so you can have automation to take action on alerted resources. We've talked about image scanning. This is certainly part of posture and vulnerability management. Squash these things before they're ever allowed allowed to run in your infrastructure. Jenkins is an open source CI/CD tool. Trivy, what you see on your screen is a capability to do image scanning. A lot of people, as they go to containers to meet some requirement, are doing container image scanning. So cool, being aware of the versions of the container OSs that you're running and the packages that are running inside them, that helps a lot to understand, the exploitability and the impact of any vulnerabilities running inside them. But, you can also scan, every time metadata is updated, which is generally quite frequently, and maybe you've got a capability to run a scan on your infrastructure. And then take action. Maybe something's fallen out of compliance because of a vulnerability being made known or aware of where it was previously unknown. And then maybe you take action by way of an admission controller. If something fails a state, it can sit there and send a notification or take action on that. But or maybe you don't have that, and maybe you're sitting there running scans against your registry and saying, hey, this has changed now. We need to do something so we're in a better security posture. It's super important, and people are doing good work with that. There's a lot of open source capabilities to do that. Trivy is one of them. Anchor is one of them. There's probably a lot of other ones. Trivy is also a capability that's built into identifying vulnerabilities in Harbor, which maybe you're using Harbor. It's an open source container image registry, and it's under the CNCF. So we've talked about cloud security posture and vulnerability management. Next on our list today is to talk about networking and the visibility gap in Kubernetes. Now we don't have somebody running around with some IPAM solution. I know for the government, for some places I used to support and visit, they would do that by Excel spreadsheet, and that made my brain hurt really badly. In Kubernetes, that would not scale. It doesn't scale for the places that are still using those. But the second that you have microservices and you have these, across the different clusters, and they're all ephemeral IPs and moving around and stuff like that, you have to figure this out, and you want to make sure that you're sort of like the Goldilocks, right? You're not overly permissive, you're not overly restrictive, and sometimes that comes down to the developers and the ops folks having a talk and saying, hey, how does your thing work? Tell us. And sometimes those are discussions that they have over lunch or easy to come by. Other times they're a bit stovepipe and a little bit harder to do. And then you have the folks on the security side that are asking the questions like, do we need all this? Is this really necessary? I think in an ideal world, I saw this. Certainly, use CNIs, use service meshes. They're to help you secure the communication among pods and containers and stuff like that. I mentioned that RBAC, if somebody could figure that out and make that really easier, they'd make a good living for themselves. The networking thing, similarly, use this. Kubernetes have network security policies, which are good, but we'll talk about that in a second. But I guess at the end of the day, it's lions and tigers in networking. And if you don't have a way to secure that or make sense of it, you might say, oh my, and that could not be a great place to be. But I think also with Kubernetes, I like that we've got this idea of this container is special purpose built. It should be talking on this port to this service or thing or whatever, and only maybe in this namespace is where it should talk to. And then maybe it's got a route out if necessary, or maybe it shouldn't have a route out because it's only local to the service that it's providing for the application. So we're getting closer to zero trust. I like that Kubernetes is sort of pushing us along that route. So I think zero trust in Kubernetes is achievable and probably being done in some areas today. Network security segmentation or Kubernetes native security network security policies. You put in some YAML, and then if you're a guru at this, I would be afraid that I would mess that up. Off you go. But I like the capability to sit there and see how the containers are interacting, do like a network topology for containers, and then from that maybe pivot back into the YAML to say, yeah, this looks good. Security's blessed this. We're all happy with that. That looks normal. It doesn't break our application. Versus, I don't know that I would trust myself. And I've got a networking background to do things the way that Kubernetes does that. That's me in my journey. With a little bit of focus and attention, I could probably overcome that. But today, use what makes sense to you to keep you safe. And then really quickly, this is for above and beyond threat detection at runtime. Yeah, you do see Prometheus and you're saying, Ryan, that's a monitoring tool. Well, I would argue things change quickly and rapidly in Kubernetes, and monitoring might be your canary in the coal mine. So check out Prometheus if you're not using it. I understand it's a beast of a tool. One day I'd like to impress friends and family with my Prometheus query language skills. I'm not there yet, but certainly a capability to not discount. You probably have Prometheus running or maybe considering it or maybe playing with it, and you're going to deploy it once it gets a little bit easier to consume. Right on. Here's Falco. This is sort of like the intrusion detection capability for containers. I mentioned earlier that this is an open source project that we created here at SysDig, and then we donated to the CNCF. The things that you see on your screen is really what it's all about. It's rule-based runtime engine. It's got over 100 out-of-the-box detection rules, and some things that you can monitor with Falco include all the things that you see on your screen. I like that Falco uses behavioral signals to detect abnormalities, and they do that by way of system calls. So maybe application A is written in one language, whereas B is written in another language, whereas application C is written in yet another language. With SysDig, or excuse me, not SysDig, with Falco, it can make sense of that because it's checking the system calls, and there's really only very limited ways to actually open a file or connect on a network port or do stuff like that, regardless of the container OS or the language that it was written in. So we'll take system calls, and then it'll also take Kubernetes audit events. And by bringing those two together and having awareness of both, it can sit there and help you understand things that are sort of not right in your environment. And similarly, if you want to get action or information out of Falco, you can do that with Falco Sidekick for all the things that you see on your screen right there. And then similarly, for a forensics capability for containers, Sysdig and Sysdig Inspect are tools that you might consider check out. It gives you really deep visibility into your containers. I like to think of it as a container flight data recorder, and it also has a capture capability similar to network packet captures, where it can show you what's gone on for some time period if you need to go back in time to check out what's been going on. Super, super helpful for security investigations and troubleshooting. At the end of the day, Ryan, you've shared some information. Some of this I may have been aware of. Some of this may be new to me. Are you secure? I mean, it's a journey, and there's not a silver bullet for keeping you secure. So I would say, are we safe? Are we secure? Well, if you're doing things that we've talked about, you're not secure. But, as you go through your journey, I guess a couple of calls to action is, securing Kubernetes is hard. There are multiple moving layers. There are multiple teams. It is a team sport. The container lifecycle is something that, is as long as you're familiar with that and addressing the different phases of the life cycle, you have a fighting chance. And then there's so many options to go about setting up your orchestrator, or choosing your cloud service provider, or getting securing those assets and platforms and stuff that, it's a journey. It's not a destination. You do want to provide risk observability. If you're able to provide guardrails to help the organization and the developers prevent inflicting self-harm or making mistakes, because they happen, you're in a better spot than you would be otherwise. And I wish there was a silver bullet, but there's really not one. So really, the defense in depth strategy is something that we talk about in DoD. It applies here too. So just be aware of what you've got, known state, how things are changing, awareness of what's going on in your environment, and then being able to take action on them in minutes versus hours, days, months, or longer, in case something happens, and so you can recover if a compromise occurs. Well, that's it for me. Appreciate your attention and listening to me chat today. Super interested to hear what you guys think. So until next time, be well. We'll talk to you soon.